The ocean is a very difficult place to make measurements. The Joint Task Force for Smart Cables was initiated in 2010, and then in 2012 we were established by 3 UN organizations: the International Telecommunications Union, World Meteorological Organization, and the UNESCO Intergovernmental Oceanographic Commission. The goal of smart cables is to get sensors into the commercial telecom cables that span the ocean and provide our society with connectivity. We want to basically ride on top of this ocean-spanning infrastructure that the telecom industry has installed. There are over 1 million kilometers of cable, and they're constantly putting in new cable, 50,000 kilometers per year, to replace aging cable and new routes, obviously. And the reason is, for cost reasons to a large extent, that we would pay our incremental share on top of that, but not the major amount. And those sensors, temperature, pressure, and seismic motion to start with, will greatly help in answering these questions about climate change and improving our predictions of climate change over time.
We are using numerical simulations and related algorithms for conducting what are called formal observing system simulation experiments, or OSSEs. And we use those to study the impact of hypothetical cabled sensors, because right now there aren't any such sensors out yet. But we use those to simulate these observing systems and then actually understand if the availability of these observations would improve our ability to, for example, reconstruct ocean circulation features, or to improve the underlying models as such. Again, something like improved calibration of the models, improved initialization of the models.
There are 2 smart cable projects now underway, and they both will be installed in 2026. The first one is off Portugal, connecting Lisbon, Azores, Madeira in a 4,000 kilometer ring with 20 sensor modules. And then the second one is called Tam Tam between Vanuatu and New Caledonia. That's much more modest, 400 kilometers and 4 smart modules. Both are geared towards early warning for earthquakes and tsunamis. Lisbon had this famous 1755 earthquake tsunami that destroyed much of Portugal, and Vanuatu has earthquakes going off all the time.
Smart Cables, as planned, will be hosting triaxial seismic sensors in each of the repeater nodes that run along the transoceanic telecommunications cables. So this would essentially provide a seismic station about every 50 to 70 kilometers all the way across the ocean floor on any of the cables that are deployed that are smart equipped. Having these seismic sensors all the way across the ocean floor, as well as offshore but in proximity to the land, would provide an opportunity to observe global earthquake arrivals for seismic waves that travel through the earth, and then they would come up and we would actually detect them in the ocean. This provides additional data that we don't have currently.
As a seismologist, the key challenges that face the Portuguese monitoring is the fast and reliable characterization of the offshore earthquakes. With Atlantic Cam, we can measure the tsunami waves at high seas and so have an evaluation of the tsunami before it reaches any coast of Portugal. We estimated that the gain is 5 minutes or more when compared to the current system based only on coastal tide gauges. This will really make a major contribution to the preparedness of Portugal as regarding the tsunami hazard.
We're still in the infancy right now. We've got a couple of pilot projects that are planned for 2026, and we have one wet demo that went in December of 2023 that had started recording data with some standard ocean bottom seismometers next to it so that we could validate what we were seeing in the smart sensors themselves. And of course there are additional sensor types that have been discussed for specific deployments, such as perhaps chemical sensors, hydroacoustic sensors, or complementary use of the smart sensors with distributed acoustic sensing, or DAS, that could be game changers in terms of cross-validation of the sensing techniques and also complementary applications.
We have a number of other projects around the world that we're in the planning process of and working with the proponents of those telecom systems. Two of note are to Antarctica. Antarctica is the last continent that has not been cable connected. So one goes from Chile to King George Island. Then the second one is from New Zealand to McMurdo Base. They both cross this Antarctic circumpolar current, a critical part of ocean circulation on the global scale.